Hello, everyone. In this video, we are going to learn how to do division with polynomials. And we have 4 learning objectives. First, we look at how to do division between 2 monomials. Then how to do division using a polynomial by a monomial. And the next 2 are the topics involving dividing a polynomial by a monomial. So let's look at these objectives one by one. First, let's look at how to do divisions between 2 monomials. We have this formula. Let's understand this formula first. Basically, this formula is the division between 2 exponential form. So notice that they have the same base. They have different exponents. These exponents don't have to be different, but generally speaking, usually they are different. And as a result, you still have the same base, and the exponent is the first exponent, subtract the second one. Apparently, our base cannot be 0 because you cannot divide by 0, right? Okay, now let's understand this formula using this example and also make sense, right? First, this division can be written as fraction form, x to the 6th power divided by x squared. Now, since we want to explain this formula, we don't use this formula directly, we do this by definition. X to the 6th power really means you multiply x by itself 6 times, right? So I get x, x, x. Now let's get 3 more. So that's the meaning of x to the 6th power. And we have 2x on the bottom. Now they are the same, no matter what they are, but they are the same, right? We know anything divided by itself is 1. That's why this canceled. Imagine there's 1 here. These 2 canceled. Now no more x on the bottom, so no more x can be canceled on the top. So we have 4x left. This 4x left times 1, so it's still 4x. So in the end, we have x to the 4th power. And that's the answer. But how we get this 4x? Initially, we have 6. 2 of them get canceled. That's why we have 4x left. So we started with 6. 2 get canceled. That's why we get x to the 4th power left. And this just demonstrates this formula actually makes sense. Whenever you do division of exponential form with same base, you use the first exponent, subtract the second one. Make sure you keep the base unchanged. Okay, now this is your first set of exercise questions. For all of my YouTube videos, you can find answers to these exercise questions in the comment area. And you can also make your own comment or ask questions. Let's move on to the next page. Now we have another formula. This formula is interesting. A to the power of 0 equals 1. And the condition is that a itself cannot be 0. Base cannot be 0. Now, the interesting part is that this a is a variable. So a variable can take many, many different values. Now, this is interesting. Regardless what a you have, what kind of value you have for a, as long as you raise it to the 0 power, the result is always the same. That's interesting, right? So we want to know why. Now, let me use specific numbers to do demonstration, so that it's easier to understand. So let's say we use 5 to the 3rd power divided by 5 to the 3rd power. And we just learned this formula from the previous slides. So when you do division with same base, your result will have the same base. And you just use the first exponent, subtract the second one, right? That's our formula. So this one is the formula from the previous page. So 3 minus 3 certainly is 0. So we get a 5 to the power of 0. So what is the 5 to the power of 0? We don't need to look further, just look at it here. This is number, we don't really care what this number equal to actually, even though I know this is going to be 125, but we don't care. We know that something divided by itself. You know, anything divided by itself will be 1. 5 divided by 5 is 1. 10 divided by 10 is 1. 1 million divided by 1 million is 1, right? Unless you divide it by 0. So this is going to be 1. Because this really means 0 power really means something divided by itself. That's also the reason we don't want this base to be 0, because that will be 0 divided by 0, right? So this is the reason anything raised to the power of 0 equals 1. It means something divided by itself. Now let's look at our second example here. N cubed divided by n cubed. And we assume that n is not 0, so we don't need to worry about this divisor being 0. Something divided by itself, we don't even need to apply the formula. This is just a common knowledge now. Something divided by itself is 1. If you want to write one more step, this will be equal to n to the 0, right? That is 1. And B. Very similar problem. This time we have a particular number instead of n. Doesn't matter. Something raised to the power of 0 equals 1 because it means something divided by itself. And that's it. This is your second set of exercise questions. Super easy, right? Okay, let's move on. We have example 3. Now this time is our example to do monomial, a monomial divided by another monomial. First, any division can be written as fraction form. So let's write it as fraction form. You don't have to, by the way. 8a to the 7th power divided by negative 4a. When we do division between monomials, we use number divided by numbers, same letter divided by same letter, because this way we can apply the division formula, which is this. I'm going to write it in here. So 8 divided by negative 4, the result is negative 2. And a to the 7 divided by 8 itself, a means a to the 1. Imagine you use, say, a to the 7 minus 1 according to this formula, right? When you do division, you use the first exponent, subtract second one. So final answer is negative 2 times a to the power of 6. Actually, you can go from here to here directly without using this formula. Actually, it's not without using that formula, without knowing that you use that formula, because you can do it from common sense. You have 7 a's multiplied together on the top, 7 a's in a row, a times a times a times a, and so on. You have 1a on the bottom. This 1a get canceled, you have 6 a's left on the top. So whenever you have same variable on both sides and they multiply together, they will call it factors. We just cancel common factors, and that's the nature of fraction, simplified fraction. It's like simplify this fraction, right? So 1a cancel, you still get 6 left on the top. Now, if we do it that way, it's much easier, this one. 16 divided by 8 is 2. Something divided by itself is 1. 2 times 1 is still 2. Oh, that's it. You can also see just cancel this m squared. Cancel common factors. Okay. Another set of exercise questions. A, B. You only have two. Now let's move to the next level a little bit. With this time, we want to divide a polynomial by a monomial. How do we do this kind of division? It's very similar to distribution property in multiplication when we divide a polynomial by a monomial. Let's take a look at it. Say, to divide a polynomial by a monomial, divide each term in the polynomial by the monomial. Let's make sense out of this statement, okay? I have two of this. The first one only with numbers, only use numbers. It's much easier to understand. So we know this answer will be 5 because 4 plus 6 is 10, 10 divided by 2 is 5. So we know 5 is correct answer. Notice that I just added two numbers together and divided by 2. That's what normally we would do, right? But we can also do this in a different way. 4 plus 6 divided by 2, right? Since this whole thing on the top divided by 2, actually it makes sense to use each component of this whole thing divided by 2. So 4 divided by 2 plus 6 divided by 2, and we get 2 plus 3. We still got 5, is that right? Yeah, we still got 5. It's like we distribute this divisor to each term on the top. This denominator shared by all of these components on the top. We only have 2 in this case. So in a very similar manner, we can do it the same way here. This is the reason we learned this division, divide a polynomial by a monomial. If we try to do it the same way here, add these two together, divide by 2, we can't. We do not add them together. But after we learn this distribution property, we can still do it by using each term on the top divided by same divisor. So this is 6x divided by 2 plus 8 divided by 2. And the result is 3x plus 4. And how do we know this answer is correct? So it goes like this. Say this one basically is 10 divided by 2 equal to 5, right? If you look at it. And how do you know your answer is right? So if you use your quotient multiplied by divisor, it should give you the divided, the first number in division. So 10 equals 5 times 2, right? These two multiplied together, quotient and divisor should be equal to the original number on the top. In other words, if you want to check if this answer is right or not, using this quotient times the divisor, which is 2, right? Imagine 2 times 3x plus 4, guess what? You got 6x plus 8. So we know this is a correct answer. So takeaway point from this this tool is that you can distribute the divisor to each term of the expression on the top in the numerator. So now let's look at our next example. So we have a polynomial, even though we only have 2 terms, but generally speaking, we can call them polynomials. So polynomial divided by monomial. So I'm going to write this into the fraction form. This equals 14x squared plus 16x divided by 2x. So using each of the term on the top divided by same 2x. Positive divided by positive is positive, right? 14x squared 2x. Positive divided by positive is positive. That's why I use plus here. 16x over 2x. Now 14 divided by 2, that's 7. this x on the bottom canceled, you only have one x left. Since there's nothing left on the bottom, you don't need to use this fraction bar, okay? Now 16 divided by 2, that's 8, x canceled. So this is our final answer. Yeah, this is our final answer. Now this one is very similar. So let's just go ahead and do the calculation. Positive divided by positive is positive. So 15x cubed divided by 5x squared. Now, second one is negative divided by positive. When you look at this term by term, you have to include the sign in front of each term. After we perform the first division, this is gone. Okay, this become part of the result. And what is left is negative 10x squared. So negative divided by positive is negative. So 10x squared, 5x squared. Now final answer 15 divided by 5, and that is 3. And 2x canceled, you got 1x left. Now 10 divided by 5 is 2, x squared canceled. So 3x minus 2. And that's the final answer. Now, this last one. Now I want to show you another way to do this polynomial divided by monomial. Actually, we don't have to go through this step. Imagine from this example that you already know we are going to use each term on the top divided by the same term on the bottom. So if I skip this step, I just look at this division. 15 divided by 5, that's 3. X to the third divided by x squared canceled, you got 1x left. Then move on to the second term, do the same thing. Negative 10 divided by 5, that's negative 2. X squared divided by x squared canceled. So we can do this without middle step. Let's do it this way. Let's try it, right? 18 divided by 6, negative 6, that's negative 3. X to the 4 on the top, x on the bottom, x canceled, you got x to the third left on the top, you got 3x left on the top. Now negative divided by negative is positive, positive 2. X cubed divided by x, that's x squared. Now 6 divided by negative 6, that's negative 1. If you have some other variables or numbers, you don't have to write negative 1 because negative 1 will multiply by others, won't change anything. But if you only get 1 or negative 1, you have to write it. So x squared divided by x, that's 1x left. So this is the final answer. They have another one, D. Let's do it in one step also. You can always do distribution going through middle steps if you want, especially if it's totally new to you. You want to avoid any mistake, you can go through the middle steps. So 24, one thing that you need to be cautious is that when you say cancel this 2, this 4 canceled, it doesn't mean this 4 canceled for others, okay? Because this is shared by all of this. So 24 divided by 4 is 6. 6 canceled, you have 3x left on the top. Negative 20 divided by positive 4 is negative 5. 6x canceled, you have 1 more left on the top. 4, this one exactly the same, both positive, so got a positive 1 left. Yep. Your more exercise, similar problems. Now our next learning objective or topic is to find an unknown factor. Basically, this is also a polynomial divided by a monomial, essentially. Now let's look at what we have here. Example 5, find the unknown factor, which is indicated by this question mark. So 6x cubed times this question mark equals 24x to the fifth. Now this one, this kind of problem actually is very easy to solve. If you realize this, say 2 times 5 equals 10, right? If one of this missing, how do you find it? You divide by the other factor. So using product divided by one factor, you get the other one. 10 divided by 5, guess what? You get 2. 10 divided by 2, you get 5. So to find out the missing factor, it's just using the product divided by the other factor. So let's do it this way. So this question mark equals 24, which is the product divided by the other factor. Yeah. Now 24 divided by 6 is 4. X cubed canceled, you got 2 more x left on the top. So that's our final answer. If you want to double check, replace the question mark with 4x squared and multiply them together, you'll get this product. If your solution is the correct one. Move on to the next one. I guess we have another example on the list. Yeah, we have 2 more actually. Let's do it one by one. But just go ahead and solve it. Only difference is that this time we have a polynomial, even though we only have 2 terms instead of another monomial, right? So solution, the question mark equals 66x plus 15 divided by 3. So 6 divided by 3 is 2x. 15 divided by 3 is positive 5. So answer is 2x plus 5. The next one, B. And apparently this is the polynomial. This is the monomial we are going to divide by to get the other factor, right? So solution. And this is a question mark equals the polynomial divided by the monomial 4x squared. And equals 16 divided by 4, that's 4. And x squared canceled, you get another x squared left from the top. Negative 12 divided by 4, that's negative 3. X squared canceled, you get 1x left. 8 divided by 4, that's positive 2, and x squared canceled. So that's the final answer. Again, if you want to double check, replace a question mark with this expression and multiply it by 4x squared, and to see if they are equal or not. And they are equal in this case. More exercise. Enough exercise is essential to gain very fundamental skills in mathematics, and it will benefit greatly down the road in the future when you learn higher level mathematics. Our next topic, how to factor the greatest common factor out of a polynomial. And let's see how to do that. We already know what is the greatest common factor, right? And this is the precise how you do that. And on the next page, I will demonstrate how to do that. Basically, it's a 2-step procedure. First, you figure out the greatest common factor among all of the terms in the given polynomial. Then you rewrite the original polynomial as a product of your greatest common factor and a fraction, which is using polynomial divided by polynomial over your greatest common factor. Let's look at the structure on the next page. Yeah, this is the structure. When you factor a polynomial, first you figure out the greatest common factor of that polynomial, and then multiply by a fraction. In this fraction, you use polynomial divided by your greatest common factor. So let's demonstrate this process using very simple question expression here to get the concept. Now, if you look at this two, you know these two numbers has 2 as the greatest common factor. Okay, so write greatest common factor first. This polynomial equals greatest common factor is 2. Then using polynomial inside parentheses, using polynomial divided by this greatest common factor. You're using this whole thing divided by that. It's not using 10 divided by this, okay? Using this whole thing term by term divided by 2 and put the result inside the parentheses. 4 divided by 2 is 2. This positive 6 divided by 2 is positive 3. Yeah, we just factor out greatest common factor 2. And don't do the calculation because it's a factoring problem. It's not a calculation problem. Actually, if I write this in detail, it makes more sense. 4 can be written as 2 times 2, 2 factors. 6 can be written as 2 times 3, also 2 factors. Apparently, 2 is a common factor. Factor it out, you just put the rest, which is 2 plus 3 inside parentheses. How do we get 2 plus 3? Because this 2 is equal to 4 divided by this 2. And this 3 equals 6 divided by same common factor. That's how you get 3 inside. That's why we use the original polynomial divided by greatest common factor to get the expression inside the parentheses. So 2-step procedure, find out the greatest common factor, then use the polynomial divided by the greatest common factor and put the result inside the parentheses. Okay, look at our example. Factor it. And apparently, y is not going to be a common factor because there's no y in the second term. And between 12 and 8, 4 is the greatest common factor. So everything divided by 4 and put the result inside the parentheses. 12 divided by 4 is 3, so 3y. Negative 8 divided by 4 is negative 2. Yeah, we just factor out the greatest common factor. Now, let me mention this. This is the right moment for me to mention that. Sometimes when these numbers getting bigger, sometimes we just cannot figure out the greatest common factor. And in that case, you don't have to figure out the greatest common factor. As long as you have common factor, it's all good. Let me show you. Let's redo this one. Pretending that I don't know 4 is the greatest common factor. I only see 2 is a common factor because both are even numbers, right? So let's go with 2. Then I put this inside. 12 divided by 2 is 6. 8 negative divided by 2 negative 4. After I factor out 2, I notice that between 6 and 4, there's not a common factor 2. So I'm going to factor out another 2. So this is the other 2, second 2. 6y divided by 2, 3y. Negative 4 divided by 2, that's negative 2. Now this 2 times 2 is 4, right? So you get the exact same result. So that's my point. When number is getting bigger, you don't see the greatest common factor. And you can go through several steps. Eventually, you're going to have exactly the same answer. And we have 2 more. We have 2 more. So next one, B. And between 80 and 45, and the greatest common factor is 9. And when it's getting bigger, you can use our factoring method we learned in the last video. You can either use a prime factorization or you can use a box division method I introduced as the second method in the last video. And 9 is the greatest common factor among the two numbers, between the two numbers. And n is common factor for these two variable parts, right? So only this exponent is a common one. 18 divided by 9, that is 2. N squared divided by n cancelled, you have one n left. 45 divided by 9 is 5. N divided by n cancelled. So that's our final answer. If you feel this is like foreign to you, you're new to this, you go through the full process. So I'm gonna do it at least once that way. So you figure out 9 is greatest common factor, then you just use this whole polynomial, write it out, divided by this greatest common factor. Because that's what it says right here. Right? The polynomial divided by the greatest common factor. Then we just need to do division. 18 divided by 9, that's 2. 2n, 9n. I forgot to put n in here. N is also common. So 9n. 18 divided by 9 is 2. N squared cancel n. You still have 1n left. Then plus 45 divided by 9, that's 5. And n divided by n cancelled. Then you still get the same answer. And the last example. And nothing more than just same work, just more terms. Now I'm going to show you that box division method to find the greatest common factor. We don't need to worry about x because for the exponential part, we just look at which one has smallest exponent. That's the easiest one to do. We have 24, we have 18, we have 30. Okay. Now we are looking for greatest common factor. In other words, you're looking for a number in here that can divide into all of this. In other words, this has to be common factor of all of this. At least I can see 2 is good because all of these 3 numbers are even numbers. They all can be divided by 2. So I use 2. The 12, 24 divided by 2, that's 12. 18 divided by 2, that's 9. 30 divided by 2 is 15. Among these 3, they all can be divided by 3. And I remember in one of those previous videos, we learned divisibility test, divisibility rules, how to determine which number can be divided by what numbers, right? They all can be divided by 3. So I'm going to divide all of this by 3. So when you're looking for the common divisor, so this is going to be a 4, this is going to be a 3, this is going to be a 5. Now, among these 3, there's normal common factor that can go into all of this without remainder. Okay. So now I will stop here. These divisors we used, multiply them together, that's the greatest factor. I remember we mentioned this in the last video. Greatest common factor is also called greatest common divisor. These are divisors, right? Multiply them together is 6. So 6 is our numerical part of the greatest common factor. How about x? 3 is the smallest one. Yeah, 6x cubed together, this monomial is the greatest common factor. Now the rest, just using each of the 3 terms divided by this and put the result inside the parentheses. I'm going to write it out one more time. Otherwise, you can write the answer directly if you feel comfortable doing that. (24) divided by 6, that's 4. 3 canceled, you got 3x left on the top. 18 divided by 6, again positive 3. X cubed canceled, you got 1 more x left. Negative 30 divided by 6 is negative 5. X cubed canceled itself. And this is the final answer. Okay. Now this is the last set of exercise. And it's also the end of the video. I'll see you guys in the next video.